Good morning again. So let's get started. Um, so in the last class, we have seen we wrote a program in the last half an hour uh, how to sort a uh, list of names. This is a program that we have seen in the last class. To summarize, so there are a few things that I would like to recap. The first is we are storing our names in a 2D array. Uh, the number of rows is given by max underscore list, which is a macro. Yeah, so the macro is right now there are 100 rows, and the size of each the the number of columns is equal to 20, meaning this, the name length cannot be greater than 20 characters, including the null character. Because strings, so we have an array of characters followed by null characters. So we should allocate memory to store that null character too. And we have these, we wrote a function read names, no spaces in names. For the time being, the particular way in which we have written read names function, so it doesn't permit spaces. But there could be other ways to take care of it. No spaces in names. That's true. So this is our read names function, which takes the 2D character array as a parameter, reads the names and stores it in this array. And then we have the sort names function. This is a bubble sort function, which takes again the names array and the number of names that is being read, and it does the sorting. And finally, print names. We print the sorted array. So read, sort, and print. So this is what we did in the last class. I hope you all understood this program completely. And those of you who had little problem in the class, hopefully you check the code after the class is over and you completely understood the code. So shall I assume that you're all good with this program? Okay. So now the question for you is, what are the problems? We already listed the problems, but I would like you to tell me what are the problems in this program? What are the problems in this program? First is names can't have spaces. Yes, that's an issue. So names usually they have first name, last name. So that's a problem that needs to be fixed. Yeah. So number two is the number of names is the maximum number of names that we can handle is 100 names. That's a problem. The second is the maximum length, name length is 20. That's a problem. Third, the name length, we kept 20, we are having, the column length is 20. Uh, so, but let's say, but there could be many names whose length is less than 20 bytes, 20 characters. So all that space goes waste, right? So these are all the problems that we have. So in this, let's try to solve the last problem, that is first, and then we will keep addressing each of these problems as we go further. So what is the problem? So this is our 2D array. like that. And so let's say if the first name is, no, let's, so Ram is the first name. Then what happens is, the whole thing, this is of length 20, 20 bytes, but you are only using 3 bytes. So 17 bytes got wasted. So on and so forth. So in every row, so if there will be some wastage of bytes, some wastage of memory. So we want to fix this problem. In order to fix this problem, we have to use null character. Yeah, null character, RAM followed by, thanks for reminding, 4 bytes. So yeah, so how do we, the way we are going to solve this problem is by using what is called as a dynamic memory allocation strategy. So let's copy this code. Let's write Control V, Control S, name sort 2.c. So here we want to change the data structure. Now we would like to use is a the data structure that is used, we are going to use is an array of character pointers. Are you able to see what is there before and what do we have right now? Just for contrasting, so this is what we have. This is what we have before. So this is there before and this is what we have right now. And the way now things it looks like is, so you have an array of it's a single dimensional array. So array entry 0, array entry 1, array entry 2, so on and so forth. So this 0 will point to memory, somewhere in memory. So RAM followed by null character. Okay. RAM followed by null character. This is what it is. Similarly, like that, so we will allocate memory. We read a string and we store that string. We allocate memory to that string or the name, and we make store a pointer to that name in this array, character array. How do we do it? How do we do it? That's the question. In many, so we use what is called as an malloc function, memory alloc function, which allocates memory from a heap. In many times we have seen before that if you look at the address space of a process, there is a chunk of space, there is a stack, there is code, no, there is a code section, there is an OS, there is code, there is data section, and then there is stack, and then there is heap. So we allocate memory from this heap to store these strings that we are reading from the as input. So that's the plan. Let's get going and we will see where we great. So you should help me out here. Read names. So what is the parameter that we are going to, we have to change this thing. Yeah, so the read names function signature, it will remains the same. Uh, so here we have to change it. And so here what we do is let's assume that the max name length is just, so we can still assume that the max name length is kind of max name length is still the same. So here we can kind of go, we can be more pessimistic now in this in our estimation of the max name length, because its impact on the memory, its impact on the, what do I say, its impact on the uh, memory inefficiency is less. No, character pointer doesn't even know what is the length of the string. It just points to the beginning. And so there is no limit. And then, so here, so we read char current name. So you do a scanf, you store it in the current name. And so here comes the interesting part. Uh, yeah, so here comes the interesting part. Uh, so so you have to allocate memory. You have to allocate memory. And what do we do? So char, sorry, names of I is equal to, names of I is equal to malloc. So let me kind of do it in multiple steps. Int length. So length is equal to current length, and then we use malloc. So and we do, so the malloc returns a array of bytes uh, of length, okay, length of whatever the value that is present in length. And it returns a address, and we have to typecast it to a particular type, because malloc doesn't know the memory that it is giving back to you, it is allocating you, whether what is its data type, whether it is a character pointer, whether it is an integer pointer. It doesn't know any of those things. Malloc doesn't have a default type. So because of that, the default type is void star. Malloc by default, it always returns void star. String length is function, it returns the length of the string, strlen. Uh, there is nothing like starting malloc. It is whenever you want it, you can call it. That's true. If we had been working on an integer array, we will pass 4-star length. That's true. So right now, since we are Now, all Malloc function, there is nothing there to teach about Malloc technique. So if you see a man Malloc, so pay attention, those of you so who have issues, just pay attention, guys. So all Malloc does is it takes a certain size as parameter and it allocates a block of memory to us. And it is completely up to us on how we interpret or view that block of memory. Are you with me here? Are you with me here? So I want you to keep this map, this memory map, which I kind of didn't write, gave quite nicely before. So this is the memory map of a process. So the OS is present here. So BIOS is present here, let's assume. And no, so text section is, this is code is present here, code section. And then there is data section. This is a rough picture. In the data section, you kind of store your global data. And then you have your stack. I'm drawing it using a dotted line indicating that it can keep moving. And then you have your heap. The memory for global variables automatically will be allocated in the data section, and the memory for static local variables will be allocated in the data section. We have seen this before. So for global variables, static local variables, and local variables will be allocated memory on the stack. But when we do an malloc, memory gets allocated from the heap. So the variables which are allocated memory in the data section, what is their lifetime? Malloc gives a continuous block. What is the lifetime of the variables that were allocated memory, that are allocated memory in the data section? The entire program execution time. The entire program execution time. Are you all with me on this one? Please pay attention. This is, but the memory that is allocated on the stack, what is its lifetime for the variables which are allocated memory on the stack? Only when there is a difference between scope and lifetime, not the scope, the life of the function is the right word to use. The life of the function. So once you activate the function and after the function gets executed, the execution of the function finishes, the lifetime will be, the memory allocated will be released. Like for example, on line number 10 here, we are allocating, uh, we are allocating yeah, text and code section are the same. On line number 10, we are allocating an array of characters. So as soon we call read names, and as soon as no, the read names function gets executed, and when we come out of it, the memory that is allocated to the current name array, it gets released. Are you with me on this one? That why local variables, when you call the function, they get the memory for them will be allocated, and as soon as we are out of it, the memory gets released. As soon as the execution of the function finishes, then uh, the memory allocated will be released. Like for example, here in these read names, again to insist. So when read names calls scanf, you enter scanf function, but the read names function is still active. So the memory that is allocated to this current name array, current underscore name array, it is still there. Are you with me? This is important. No, no. So now this is the reason why I'm asking this question systematically is uh, the reason why the memory that is allocated through malloc, it will not be released after we come out of this read names function, nothing like that. we have to explicitly free it. We have to explicitly use a function called as free function in order to do this. The memory that is allocated to Malloc, its lifetime is decided by you. You are the master of the memory block that is allocated. You allocate it and then you deallocate it. How you deallocate it is by making use of another library function called as free. Like later on, for example, if you want to free this memory, we use free name size. Then the memory that is allocated, it gets freed. Are you all with me here? The lifetime of memory blocks that are allocated through malloc, it is governed by you. That is, you have to allocate memory and you have to release memory by yourself. No, the array doesn't get destroyed. It's just left as it is. And so whatever it can be used for other purposes. The memory can be reused for other purpose. So anything can happen. So yeah, essentially it's not in your control. What if someone forgets free? We will deal with it. Okay, but when your program exits, then everything gets automatically freed. That's true. malloc memory is freed anyway after the program completes. Uh, so the lifetime is still, there is no scope. You can just pass that memory around and it can, there could be, so there are few cases, I think there are few questions coming up with coming up on the chat box. All of them are important questions. I will take them after a bit. But right now, I want to check if you are with me till this point. So what I want you to understand here is, what are we doing on line 13? On line 13, we are reading the name into current name local variable, and we are allocating memory, and we are copying that. We have to still do this. So we are not done yet. So we have to do strcpy. Strcpy is string copy. Destination is names of I, and the source is current underscore name. I have to put a semicolon here. Are you all with me here in the read names function? So we read the name in a temporary buffer and copy it into the memory chunk that is allocated on the heap. This is the idea. Let's see if we did this job right. So before we kind of call, so let's comment this code. So we are just reading names and printing names. So why do we have string copy? Because we are reading current name is a local buffer. We are having some 100 length. Okay, so whatever the name, we are storing it in a local variable called current name, local array, but it's not permanent. Okay, so we want to store it in a list. So we want to allocate memory to that name in the heap, and copy the name that is there in the temporary buffer to the heap. So if you want to see the story, how you want to get maybe a clear picture, I'll draw one more diagram. So here is, this diagram could be useful. So we start with main. And we call read underscore names. So if you look at the stack, in the stack initially, this is the activation record associated with main, and then so after when we call read underscore names, the activation record associated with read underscore names will be here. So where will current underscore name, the memory for current underscore name will be allocated? Where is array? So the current underscore name, if I'm allowed to use a shortcut CN, the memory for this array CN is allocated on the stack here. And if we kind of zoom this CN is a array, right? So sorry, yeah, not CN is not an array. So let me, and yeah. And then what we are doing is we are passing, let's do one more thing. And so what we are having is, let me do one more thing. What is that we are passing here? And these char star names, these names, this is this array of pointers names. It is present in the, where is it present? Let me go back here. Yeah. And the names array, it is present, its names is present in the activation record of the main. Remember, this is activation record of the main. This is names. So here when we are updating these names of 0, names of 1, etc., if we kind of blow it up, so what happens is, what is happening here is this is our names array. This is names 0, names 1. So what we do initially is, let's say in the first string that you read is Ram. So this Ram followed by null character will be stored in the CN array. And so you create some memory in the heap by using the Malloc function, and that will be copied from here to heap. This is from the heap. Okay, so in the heap you store Ram followed by whatever that thing, and you make this point to this. This is what happens. Are you all with me roughly? Yeah, string length will include /0. I think so. Yeah, string length will include /0. Yeah, let's go ahead and run this program, and I hope it's all. I didn't test this program. So string length doesn't give /0. Okay, sorry then. Yeah, it seems string length doesn't give /0. So what we should do is we should put a +1 here. Okay. So it seems string length with it doesn't include the null character at the end. So when we are allocating memory, so we have to add one more character. But string copy will do it. String copy will automatically have a null character at the end. Okay, let's compile this program and see where we are. It is in which directory? Sorting directory. GCC. I see a lot of class is silent today, so exactly not sure. So what include files I should keep? I should have stdlib or malloc.h, hash include malloc.h. Passing, print names is different. Okay. Char star names. Are you with me here? Line 27 to 31. How we are doing print names? Are you all with me? Lot of class is silent. I hope you are all tagging along with me. Yeah, Malloc.h is what I. Great. So now let's compile the program. Okay, so nice. So we are able to successfully, so we are able to successfully read the all the characters, all the strings from the file. So are we good? I don't worry about the call stack diagram, Vivek. I think it is drawing the call stack diagram for this is a bit not complicated, but painful. All I want you to tell is this: in the read names function, what are we doing? We are reading a name and storing it in a temporary buffer called as current underscore name. Are you with me here? First step. So let's take a step back and let's see all of you are with me. Number one, in read names function, what are we doing? We are reading the name and storing it in a local array called as current underscore name. And then we compute the length of the string that is present in that array. And based on that, we allocate memory on the heap on line 17. And then we copy the name that is present in the local array to the heap. And names underscore I will point to the memory that is allocated on the heap for it. And this is how the whole read names function will work. And for print names, so we are just we are passing an array of character pointers, and so we just print, we just iterate and then we print. That's all. I don't know whether I'm just repeating the same, whether I'm making sense or not sure. For you, the key thing to understand is the data structure that we are using is is an is a call stack diagram is nothing but no you main calls read name, how the activation record looks like. That's like that. Okay. So the most important thing is this. This is your array of character pointers. This is your array of character pointers. So here this will point to something in the heap. And the next thing again, it will point to something in the heap. And again, this will point to something in the heap. Again, this will point to something in the heap. So this is 0, this is 1, this is 2, this is 3, this is what we are doing. That's true. One is a character array and other is a character pointer. Array of character pointers. So if it makes it anything more clear, if you kind of write it like this, please pay attention here. If you kind of pay attention like this, on line 60, you have char star. So when we say int names, the type of the number of names is integer. Yes or no? Those of you who are a little bit confused, please pay attention. What is there on line 61? The variable number of names, it is a integer. It is of type integer. Yes or no? Are you with me? I want those of you who are a bit confused to follow this thought process that I am guiding you through. Are you fine with line 61? line 61, it is you are declaring its number of names, it's a variable and it is of type integer, 4 bytes of memory is allocated. But if I say int names 20, then again, so names is a variable. So let's say names, let's say whatever, roll number. Yeah, maybe it's not a good name. So let me use int block. So now compares line 61 with line 62. On line 62, so the variable blah, it is of type integer, and not, it's just not an integer, it is an array of integers. And why is it an array of integers? Because there is a qualifier, no, so it's square brackets 20 within square brackets followed by blah. Are you with me here? This is an array of integers. So scalar variable of type integer. So again, if you say this is no, this is an array of integers. Blah is an array of integers. And then if I say int star blah, what is it? Let me, before I go here, let me say int star ptr. Okay. So this int star, don't pay attention to. So what is its data type? In order to understand this, scalar is not opposite of dynamic. So int star pointer, what is it? What is the ptr variable? It is a pointer to an integer. Pointer to an integer. Yes or no? It's a pointer to an integer. Are you all with me here? Address holder for an int value. Okay. So now let's extend this argument int star ptr array of 20. So what is ptr array now? What is ptr array? 20 address holders, exactly. Or a pointer is nothing but an address holder. An array of pointers to integers. This whole thing, think of it as one entity. That's true. So 20 pointers to 20 oh no, not to 20 integer arrays, pointers to 20 integers. To 20. So maybe the right way to do it is pointer to integer, array of. Pramod, I will hold on to your question for a moment. Does this make sense? Does line 65 make sense? So now what I would like you to do is similarly, let's take the same exercise here. So char C, it's a single character. And char, char C array of 20. So what is it? It's an array of characters. Are you with me on line 67 and 68? They are simple, right? Array of characters. And then we say, what is char star C? It's a pointer to a character. It's a pointer to a character. Now if I say char star c of 20, what is it? Array of pointer to character. Pointers to 20 separate characters. But the interesting thing is in the line 70, if you see, no, CPTR array. The interesting thing in line 70 is the characters can be the beginning of the string, and that is where we get the power. So if you look at the CPTR array, what is happening here, if you see, so this points to, so this points to a character, and this also points to a character. So, but the character can be the beginning of a string. Like for example, in our case, we have no, so Ram, our favorite name. So this is technically pointing to the beginning of the character, but it is possible for us to, mentally we can think, no, it is, we can have a string at that place, and all we need to do is point to the first character uh, of that character array. And this can be present in the heap or this can be present in anywhere, it doesn't matter. All it means is this is pointing to a character. So I don't want to take more difficult questions, but I just want to check, are you with me here? Are you all with me till this point, this character array? So I just want to take simple things, basics we should get it, and then the optimizations, etc. You can look at it later. So the important thing is what Pramod pointed to is on line 60, this whole array, where is this whole array present? This whole present is, the whole array is present on the stack. But like these names are allocated memory from the heap. This memory is allocated on the heap, and whatever that is present here, it is coming from the heap, so on and so forth. Those things wouldn't happen. So you are, when you do, you allocate no, this memory using Malloc, you allocate this using another Malloc call, so it wouldn't be a problem. So they should be, as long as you have that no, that null character at the end, you don't overrun to. So the memory that is allocated by Malloc using different calls, they don't interfere with each other. No, see, Chinmay, the way to think is each of these character pointers, they are pointing to a memory location which is holding a character. But logically speaking, from after you can have no, like after that more characters could be present. That's what we are doing here. When we are working with strings, that's true, because that is because the particular organization that we have used on line 60. On line 60, we are saying we are having that our names array is a local variable. Because of it, it is present on the stack. No, 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 no. So char star star. No, think of it. So all you are doing is this address. This contains the address of a memory location where character is present. This contains the address of an memory location where character is present. Because of that, we just say it is char star. That's all. Which problems earlier, for RAM we allocated 20 bytes of memory. It is pre-allocated. No matter what the name is. No, stack doesn't contain characters in my. Stack contains character pointers. Okay, I want to take a deep breath for myself, and we can also take a deep breath. Uh, want to do a quick check. How many of you are with me, or is how many of you are with me? Is it a pointer can point to anything, any address. It can be on the stack, it can be on the heap, or it can be anything. And pointer doesn't know anything about it. I see some of you are having problems. That's true. A pointer only has a memory address. It doesn't have any other information. No, it doesn't have information about type. Because of that, there is no differentiation between int star and char star. We can't use malloc on stack. Let me try to see. Let me try to stop share. So, uh, yeah, maybe let me give a shot in the next 10 minutes, and if it doesn't work, I'll come back again with a more concrete theory. Okay, let's try to get these things. Okay, let me give a shot. Int and int star. When we say that a variable is of type int, what does it mean? So I would like to take a pause on no, the discussion on the chat box. I know it is important, but I guess some of you are confused. So I would like to clarify it, these ideas. So please take a short break on the chat box. So what is an integer? So when we say variable is of type integer, what does it mean? It holds a object which is of type integer. Yes or no? So there is an integer. So let's say there is an integer, and so this is a memory that is associated with a variable. And when we say that int var, then that means variable is referring to a memory location which is holding integer. Right? And when we say int star var pointer, then that means, what does it mean? That var pointer is pointing to a memory location which is of type integer. This is an address. This is an address holder, and holds the address of a memory location which is holding an integer. Are you with me on these 2 points? We looked at it before. Great. So now if I say int star var ptr array, then what do I have? We will talk about stack and heap, etc. later. So this is an array, and what it does is, so it points. This is 0. This points to an integer because it's an array of address holders. It's an array of, when we say int star var ptr array. Sorry, we need to have 10 or something. It's an array of address holders. And each of these things, they are of type integer. So this is of type integer. This is of type integer. This is of type integer, so on and so forth. You replace int with char, the same theory holds. Are you all with me till this point? Whether int or char, it's not going to matter. Good. And these integers, these integers, they can be local variables, or they can be global variables. They can be allocated memory from the stack. These objects, these integer objects, they can come from anywhere. The pointer doesn't know anything about it. Are you with me here? Again, this is an important thing. So these integer objects, they can come from, like they can be in the data section. They can be in the local section. Local, no, sorry, this is stack. They can be present on the stack, or they can be present on the heap. Anything is possible. So the pointer, no, it doesn't know anything about it. I hope you're all with me till this point. If you're all with me till this point, so if you now extend this idea, and say you have char star, let's use names 10. So this is 0, this is 1, this is 2. So this points to a character. This points to a memory location which holds a character. This points to a memory location which holds a character. This points to a memory location which holds a character. By the particular way in which C is organized, if you take a string let's say a string such as RAM, which is allocated memory somewhere. So RAM followed by null character is there. So this is pointing to a character, but from the logic, but the logic with which we allocated memory tells us if I know the address of R, then I know the address of the whole string RAM. Are you with me here? But this is not guaranteed. But the way we did our malloc, the way we did our string copy and all those things, we did it in such a way so that when we know the address of the first character, we know the address, base address of the whole name, this particular name. Are you all with me here? Yes or no? Some of you said you didn't understand before, so I'm repeating for your sake. Uh, I didn't have the heart to move on. Although many of you said yes, I want to see those few students who have trouble. So, are you with me? This AM followed by null, it's not automatically guaranteed. It is through program we are doing it. We are setting up things in such a way so that when you know the address of R, you know, like you can go on till you hit a null character, and that gives you a particular name. No. See, yes, it's very, very important. Malloc doesn't know anything about your character business or whether it is allocating memory for integer character. Nothing it doesn't know. All it does is it allocates memory. Here, like for example, when we, in order to allocate memory for this, what do? Malloc 4 we do. How did we get 4? We get 4 because we used string length of CNAME. That is the current string name. This is what we have read using scanf. We got 3 and we added 1 to it. And then it allocates a chunk of memory and it gives the address of that base address here. So malloc gives a chunk of memory and it gives the base address of the chunk. And what is so here it gives a chunk of 4 bytes when you call it with malloc 4, and it gives a chunk of 4 bytes. Remember, we have to use +1 here because string length gives only 3 characters. We have to add 1. So we call malloc 4. So malloc gives the base address. And then so after we allocate, what do? We do a string copy of names of 0. What does names of 0 contain? Names of 0 contains so this is what we did here. Just want to recap here. So we have length variable, and then we used string length CNAME. CNAME is the current name. I'm just using it as a shorthand. If CNAME is if RAM is the input, then CNAME returns 3. So what we are doing is, and then we say names of I is equal to malloc of length length +1, because we have to, and then we have to cast it also. We do char star, and then after that we do str copy name side, and what is that scene. Are you with me? So before I ask I take more questions. Uh, are you with me here on this? What we are doing in this chunk of code? Are you all with me here? And so why is this character names array, it is on the stack? This array is on the stack. Why is it on the stack? Why is this array is on the stack? Because it's a local variable. The memory for this whole array, this whole array is a local variable. Because of that, it is allocated on the stack. And since we are using malloc for allocating, so it is all coming from heap. All these things are coming from the heap. So there are 2-3 questions here which are important. See, what happens is how Malloc works. If you see remember, so let's say if this is your address space, in this address space, this is your heap. What Malloc does is it keeps track of the chunks of memory. Like for example, it can say this chunk of memory is allocated, 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 like that. So if you don't, like for example, you ask for 4 bytes and Malloc gives this, okay, and but then you just don't respect it. Like for example, if you don't add null character here, and when you keep trying to read that string, it keeps going on here, and you'll end up writing some other contents that are present in Malloc, and that memory, if it is allocated to some other request, then we will get into trouble. So what would happen if you don't if you don't add +1 to here? If you don't add +1 to here, you will be allocating only 3 bytes. And when you do a string copy, what will happen? So, no. So this is what happens if you just, if let's say, if you don't add +1, let's say you remove this. Okay, you remove this. Then the memory that is allocated, let's say the name is Ram, then the memory that will be allocated is 3, and names of I will no. And then when you do a string copy, then what happens is RAM followed by /0 will be copied. Then what happens? What happens is if this 0 kind of overflows into a block which is allocated to some other request, then that block gets spoiled. Are you with me here? Because what string copy does is, it copies RAM and then null character to the address that is given to it. So what happens is, like for example here, let me, yeah. So let's see. Let me use a different color. So this is, let's say, RAM gets copied. Let's say if this is allocated, and then you put 0. You will be all right if this memory, if this null character, doesn't get into another block which is allocated using some other malloc call. Yeah, string copy relies on /0. That's true. String copy, all string manipulation libraries, they assume strings end with a null character. If you don't have a null character ending, then you'll get into trouble. You don't know whether RAM is terminated. So when you read RAM, when you do a scanf, you know that it comes with a null character. What do you mean, Anirudh? I didn't get your question. Huh. I think you are not you are not missing the point. You are completely missing the. Yeah. So what Kishore said is true. I don't know. I could be boring some of you, so I'm kind of. No, since C, that is the thing about C. You don't. It is your job to handle. When we work with dynamic memory, that's where all the problems come. You don't. This is a. You are having a mental. There is a. Uh, so there is a mental map. There is a memory on the heap, and you are kind of working with requesting memory, releasing memory. Okay, guys, this is what I want to tell. Okay, one more time. So let me. There are two things that are going here, guys. So you are. We should let's try to get this right. On one side, there are string manipulation, strings and string manipulation functions. When we are using any of these string manipulation functions like string length, the string copy, or any of these things, the notation, the, the convention that we use is there should be a null character at the end. Are you with me here? Let's take a moment and this is about strings, nothing to do with malloc, nothing to do with heap, nothing to do with anything. All it says is when we are working with strings, usually we work with, so the default case is it should end with a null character. And the important thing that you need to keep in mind is when you do an strlen of a string, the null character is not included in the string length. So let's say if you want to copy ROM to some to new place using string copy function, the destination should have at least 4 bytes of address because null character will be automatically included. Are you with me here? These are the two things I want you to keep in mind. strlen and strcopy, for example. So strlen doesn't include the null character in its length. And strcopy, when you're copying the source to destination, it is your job to have enough space to include the null character because that's what strcopy function does. I hope you're all with me on this with respect to strings. So shall I move on then? Anyone having problems here? Then you should ask me. Otherwise, we will move on. Okay. On the other hand, we have heap. So I'll just heap is a chunk of memory. Let's think of this just as the whole thing as the heap. This is the whole heap which is extracted from the memory. So the way you deal with this heap is through malloc and free functions. Is to use malloc and free functions. What is the guarantee that is given by malloc? The guarantee, so how do you make a call? malloc, some size, okay, whatever, no, some 100, 200, whatever it is. So when you call malloc with a given parameter, what it does is it returns a, what it does is it gives a chunk of memory. Okay, so it gives a chunk of memory and then it can give a chunk of memory here, it can give a chunk of memory here. So subsequent calls to malloc, it doesn't give any guarantee that the blocks that are allocated are contiguous to each other, or none of those guarantees will be given. And then there is a free function, uh, and then there is a free, and free takes a pointer. So like free, uh, it's a pointer it will take, it will free the memory which ptr points to. This is the interface that is given to you, but let's say you got this chunk of memory by this call, but you didn't respect these things, you went ahead and used all these things. then there is no guarantee about what happens, no, because you are either the place here, it could have been allocated memory for some other MLOC call, right? Or and or it could be empty. Anything can happen. Are you with me here? So MLOC and free, it doesn't know anything about how you are dealing with the memory that they have given to you. So all MLOC does is it keeps track of the whole information that these are the blocks that I have given. And when a new call comes, this is how I should allocate memory. And if someone frees the memory, this is how I should take it into free pool. All these things the heap does. And it is your duty to respect this thing. It is your duty to respect this. That's true. MLOC internally has a data structure when you do, like for example, when you do PTR is equal to MLOC 100, and when you do free PTR, it exactly frees 100 bytes. If we don't tell the size, good question, Pratyaksh. No, no, it free also, it just takes a pointer. It doesn't care about the data type. It just takes a pointer. It need not be character or it. So if I am right, MLOC internally keeps track of a data structure which says the memory that is allocated starting at the address PTR, it is of size 100. That's true. That's what Kishore is saying. Let's not worry about real log for the time being. So we will talk about real log. So Malloc internally maintains a data structure. So Malloc is like kind of it's a library function which it maintains lots of information. So across Malloc calls, it keeps track of what is happening where, and what is the allocated list, what is the free list, all that information it maintains in order to carry out memory management. Are you with me on this one, on the heap thing? Yes, Malloc works for structures. Let me, in order to kind of make it kind of clear, in this heap or somewhere, so kind of Malloc kind of keeps some kind of metadata. What is the metadata? Like for example, a metadata could be like for example, a list of tuples. A list of tuples is starting from memory address 100, I allocated 2000 bytes of data. Starting from memory address 150, or let's say 450, I allocated some 30 bytes of data. Like that, it kind of keeps a metadata, and it uses this metadata in order to take care of the subsequent malloc and free calls. This is a very big picture, so let's not get into the details. Roughly, this is what malloc does internally. It returns a null pointer. Okay, are you happy? I was a bit not sure about today's class because I felt I kept repeating the same stuff again and again. So whether how you were receiving it, yeah. Okay. Okay, good. So now let's try to finish our program, guys. Is it okay? Is it all right? Shall we go back and finish our program, or do you want to call it a day? So let's finish the program. So yeah, so you want to sort the names. So you pass names and number of names, and what do we do? Yeah, sort names. I have to change char star names, You compare string compare names of. See how the code modifications are happening closely. You're comparing the two names pointed to by the pointers present at the location j and j plus 1, and if we have to swap, we swap this way. So now let's not get into that. So are you happy with this one, with the code changes that I made so far? You will read man page of string compare Karthik. Are you fine with the code changes in the sort names function? Does it make sense? Is it good? Line 29, do we need ampersand? Line 49. How many of you think we need ampersand on line 49? I'm thinking we need ampersand, but how can you change names j and names j plus 1? So that's the reason why I found this program interesting. So these are the two consecutive locations. We want to swap them. If you don't pass the addresses of these two, how can we change them? No, they are pointers, but they are pointers to strings. Names j, it points to this, and names j plus 1, it points to some other string. But we want to switch these two. So we need to know this address and we need to know this address. No, we want to, these are the, this is jth location, this is j plus 1. We want to swap them. In order to swap them, we need to know the addresses. Otherwise, swap cannot, will not be able to swap the contents of them. So now my question again is, do you think on line 49, do we need ampersand or not? We are not. So this is the interesting part. This is the interesting part. The interesting part is we want to swap these two. The way we are going to swap is we swap after we do the swapping. What happens is, the whatever that is present here, it will be pointing here. Whatever that is present here, it will be pointing here. This is something an interesting thing for you to think. Uh, yeah. So what is the signature that we should change here? How should the swap function should change? The swap function is, it's a pointer to a pointer, right? And then do we do string copy? This class is going to be, I want you guys to think about the programs, the discussion, all we did in today's class. Does this make sense? Let's see if it works or not. And then we will, this is going to be a tricky thing, name 2. Line 72. Ah, sorted list. String copy doesn't care about where the address is coming from. How many of you understood what is happening in the swap function? What does str1 contains here? What does str1 contains? What does str1 contains? So str1 contains, this is names j, it points to some character array. This is character array. Similarly, this is str2 points to names j plus 1 and it points to some character array. Before we kind of look at an alternate strategy, I want those of you who got confused to pay attention here. Can you pay attention here, because we will close this lecture in the next 5 minutes. So what are we doing here? So str1 contains the address of names j. So what is our end goal? Our end goal is to see that names j points to this and names j plus 1 points to this. That's what we want to use the swap function for. And what we did is we passed the address of names j and names j plus 1 in str1 and str2 here. And when we do str1 is equal to temp, what does temp contain? What does temp contain? What does temp contain when we do star str1 is equal to temp? When we just use str1, when we just use, please pay attention here, if we just use str1, let's say the address associated with names j is 100. If I just use str1, then what we get is 100. But if I use star str1, then you go to this address, okay, and you 100 contains no. So whatever that is present here, this is what you refer to. This is what you refer to. Okay, let's say this is some, let me call it as xxxx. Okay, and this is yy. So the value that is referred to by star str1 is this xxxx. So this now temp contains this thing. And what is this xxx? This is the address. So now when you do star str2, let's say this is 200. This is 200. And this is also 200. When we do star str2, that is, no, str2 is 200, star str2 is yy. So what happens in this statement is when we do star str1 is equal to star str2, this gets copied here. Are you with me till this point? I want you to pay attention here before you. Are you all with me here till this point, what we are trying to do in this picture? And in the last line 39, what we are doing is temp now contains this xxxx, okay? And that will be copied to star str2. So here, this yy will be overwritten with xxxx because of this particular statement. So what we are doing is we are swapping the contents of these two names j and names j plus 1 through this swap function. And after that gets executed, this xxxx is the address of this array and yy is the address of this array. So after we do this swapping, so names j plus 1 will point to this and names j will point to this. This is a summary picture, guys. That's all. Okay, this is the whole story of using array of pointers. And how many of you are with me completely at the end of this whole discussion? Good, good. So Frame, don't Google around a bit. You should just, I will post this code. I want you to take a look at this code and work through it carefully from the scratch. This is the key here. So I know there could be good explanations in Google, so but you should try to trace through this code and see what is happening, what is being passed and what is being, all those things. Okay, I think we should stop here. Uh, I know it could be pretty tiring for you. I will upload the